Okay, today I will be discussing with one of the question that was asked in TCS Codevita round 2. The question was like the student, I am not actually exactly can remember what was the question. The question was like we are given a number 1, 2, 3, 4, 5, and every number has and this is the number. This numbers has the digit like 1, 2, 3, 4, 5. Every digit is placed to its original position 1, 2, 3, 4, 5. This is the position. This is the position, and this is actually our number. And every digit position is like that. The question was like how many possible number arrangement, how many arrangement I can make so that at least one digit, at least one digit will take its at least one digit will take its position, and the digit is numbered with its position like 2 is the in the position of 2, so the number is 2. The 3 in the position of 3, the number is 3 in this way. So how many arrangement I can make so that at least one digit will take its original position? Like for example 1 in its original position. What about the others? I don't care. Maybe it will be 3, 2, 5, 4. You can see that no numbers other than 1 is in its original position. So it is allowable. It is allowed, right? Like at least one number. Maybe 1, 2 is in its original positions, and other than this, I don't care. Like here is a 5, 3, 4. It is not in its original position. Maybe in its original position, I don't care. Okay. So 1 and 2 in its original position. So this was like the questions. Maybe 1 and 3 in its original position, and other than this, that's all. I can arrange any kinds of the way. This was not exact question. The exact question was like a student and teacher. Student and teacher. The teacher have to check a few paper, and every teacher after checking it will give the answer sheet to the student back after correction or after checking. But somehow there was some prankster was there. This question was like that. The prankster was there. This prankster have shuffled this every answer sheet. Now the teachers have to identify that if the papers have reached to its original student or not. So how many ways it can take it? At least one per paper must be to the correct positions. Others may not be. Or to 1, 2, 3 students have got its answer sheet. Others 2, 4, 5 have not received. So how many these types of arrangement is there? So this was like a question. So the teacher was interested to take that how many ways it can take like that. So the summary of this like that was. So whenever these types of the problem comes, that's at least one number should be in its one original positions. Others number I don't care. Then the idea that will come, that is the derangement problem. Derangement problem. We know that what is the derangement. The derangement, like we have an array. 1, 2, 3, 4, 5. and its position is 1, its position 2, its position 3, its position 4, its position 5. The derangement problem was, if it is our array, then array, the digits of every positions of the array should not be equals to its position. It was the derangement problem. Whatever I have already discussed that one. But I have discussed that at least one should be. So it is like an, and here it is in the derangement problem, no one should be in its original position. So total, so our problem solution equals to total number of ways, total number of possible arrangement minus derangement problem solution, derangement problem solution, right? But whenever I am going to solve the derangement problem solution, then the derangement problem solution we have seen that it equals to total possible number of ways minus at least one number should be in its correct positions. So that such ways, how many, that is the derangement problem. So total number of ways minus at least one number in its position. That was the solution of the derangement problem, right? So our interest is not the derangement problem, because the derangement problem says that no one should be in its correct position. Our interest is at least one number in its correct position. But whenever we are solving this, we should take the idea of the derangement problem, so that I can come across to the that it is taking as the at least one number in its correct position. So our interest is this. Let's solve this one, that at least one problem in its original positions. So before that, I have to take some rough idea. How? Suppose I have 1, 2, 3, 4, 5. Suppose one number I am fixing in its original positions. I don't care what is the others number is. So what is the possible number of ways here? That is the, if there is a 5 total number, then one number I am fixing. So the 5 factorial should not be there, because one number is fixing. So how many other than 1 is 4. So the 4 factorial total number of ways is when one number is I am fixing. One digit I am fixing, then 4 factorial total ways I am getting. The same way, when I am fixing the 2 number, then other than these 2 numbers, also I can take it as the 4 factorial ways, because other than 2, how many digits are left? 4 digits. So how many total number of ways I can take? 4 factorial. So it is the same like 3, 4 factorial, same like 4, 4 factorial, same like 5, 4 factorial. So 4, how I can take 4? If n is total number of digit, here is like 5, then what is the total number of ways? Is nothing but n minus 1 factorial. Here is 5, n is 5 minus 1 equals factorial equals to 4 factorial. I am getting 4 factorial, right? So n minus 1 factorials way I can take if I am fixing one number at a time. But how many such numbers is there? How many such arrangement I will make? 5 total arrangement I will make. Because if each number is taking this operation, total 5 number I have, total 5 number I am taking. So if total 5 number is taking, means for one number, if the arrangement is n minus 1 factorial, then for n number, Here n is 5, it is the other word. So for the n numbers, it is n into n minus 1 factorial. So these many ways I can make if I choose one number fixed at a time. Okay. In other word, can I make it like that? N choose 1, n minus 1 factorial. N means n minus n choose 1. Right or wrong? N means n choose 1. Means out of this n, how many combination I can make, so that how many combination I can make out of this n. If I take at a time one number, how many combination I can make? 5 combination I can make. So out of this n, if I take one number out of this, so one numbers, how many combination I can make out of this n? It is nothing but the n choose 1, n combine n combination of 1. Again listen, out of this n, out of this name n, how many ones combination I can take? If it is n choose 2, then how many twos combination I can take? Means it is 1 2 3 4 5. How many two combination I can take? How many two combination I can take? How many two combination I can take? Combination means we know that there will not be there should not be, the numbers is not equal. Like 1 1 3 we have, 3 1 should not be there, we know about it. Other than but yeah, 1 4 if it is, then okay, this is the different than this, it is the combination we know. So in this way, if I take two numbers, then how many such combination I can make out of this n number? This is the NC2. Here is the same. Out of this n, if I take at one time, if I take for every combination, if I take one number, the how many such combination is possible out of this n? It is nothing but the NC1. So can I make n as the NC1? Yes. Why I am making NC1? I will show you. So this is the one NC3 n minus 1 factorial. Why I am making like that? Because when I am fixing one positions at a time, then it is possible that there is so much overlapped. So by overlapped, when I am choosing, suppose we are making this number fix, this number I am fixing, and then arranging this all. In the second time I am fixing this and arranging that all. It is very much possible to overlap with each other. So that I have to also choose the NC2. I have also to choose NC2, and I have to make ignore this all the NC2. I have to make minus of the NC2 out of this all the NC1. Is it the only NC2? Means I am choosing two elements at a time. Is it only two elements? If it is three elements, like that, if it is three elements, it is also possible that when I am choosing the 3 element at a time, other than 3, if I arrange them, then also it may have overlapped. So n choose 2 is also possible. Also I have to minus. Okay. So when I am making it, I have some problem. The problem is when I am choosing one element, the problem is that it made possible that 2 or 3 numbers overlapping with each other. 2 or 3 numbers is overlapping with each other. Like 1, I am fixing 1, and I am getting 1, 2, 3, 4, 5 by arranging other than 1. Then it is possible when I am fixing 2 numbers, then all the others number when I am arranging, this is possible the same number like 1, 2, 3, 4, 5, the same number can happen. So I have to ignore them. So when I am ignoring them, then I have an idea that this is the problem like inclusion and exclusion. Inclusion and exclusive problem. What inclusion and exclusion problem say? Okay, so the S, if I am taking one first number when fixed, this is the one number, then this is the formula. So I am marking it as the S1. For the second fixed number, I am marking as 2. In the same way, when the n number fixing, this is the S3. So we know that in the inclusive exclusive formula, what is actually our formula? The S1 union S2 union S3 union S4 dot 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 up to union Sn. This is actually our formula. We know how to solve this formula. What is the formula? What is the so what is our formula? So when this is the answer should be like uh, S1 plus H2 plus H3 dot 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 up to Sn. But so this is our minus S1. It is better to take it. It is not taking like that. It is better to take it in this bracket. Minus what I have to make? Minus S1 intersection of H2. This is the inclusive exclusive idea formula, because this I have when I was solving the problem, we have seen that this is falling into the inclusive exclusive formula, so that I am making this formula. Okay, so S1 intersection of H2 plus S H2 intersection S3 plus maybe S1 intersection S3. In this way it is making all the two A's intersection. Out of this n 1 2 3 4 5, for taking this example, all the 2 A, how many combinations are there? All the 2A's combination I am making. Okay, in the similar way I am making 3 combination, because it is possible by the 3 combination, whatever the result is, it may possible to overlap with each other in this way, in this section. So also I have to ignore it. So I am just making the 3 way all the possible. So 3 way how it is? S1 union S2 intersection S2 intersection S3. We know about it. Plus dot 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 up to all the 3 ways intersection. All the 3 ways intersection. In the same way, we know then the sign will be minus. All the 4 ways intersection plus all the 5 ways intersection. In this way it is going on. So this is actually a formula. But we know the formula, but solving the formula very difficult, but it is not difficult. We know its formula, what it is formula. If everyone is taking n into n minus 1 factorial, everyone is taking n into n minus 1 factorial, then we know that n, I can make this n as nc1, n choose 1. How many total these kinds of the variable is possible? N choose 1. N minus 1 factorial is for each one. Total how many? N choose 1. Okay. So this one, what will be this one? This one will be, if each time I am taking two number fixed, what are the others number? If each time I am making two number fixed, what are the others number? N minus 2. How many total arrangements such possible? N minus 2 factorial. How many total such operation is there? N choose 2. At a time, for one operation, for one arrangement of the S1 union intersection S2, I am choosing n minus 2 factorial. Why n minus 2 factorial? Because other than two fixed numbers, I can make arrangement of n minus 2 factorial ways for one such combination. How many total combination is there? N choose 2 combination is there, because total is n number. So n choose 2 n minus 2 factorial, this is actually our total formula. I can make it. In the similar way, if you have understood this one, the similar way I can also make this all the 3 ways combination. I can make nc3 n minus 3 factorial. In the same way I can make also this, that nc4 n minus 4 factorial. In the 5 also I can make okay, the 5 also I can make like nc5 n minus 5 factorial. So what is our total answer right now? If I understood this, then what is our total answer? First was NC1 n minus 1 factorial, then is minus, then n choose 2, n minus 2 factorial, then this is plus nc3 n minus 3 factorial. So in this way it is going on. If it is going on like that, what is our final answer? Can I make it like that? I equals to 1 to n choose I, up to n it will go, n minus I factorial. Can I make it like that? So this is the total number of arrangement that have at least one number to its original positions. Maybe other than 1, 2, 3 position also can be fixed. Understood? So this is actually our total number of arrangement. This is total number of arrangement, so that at least one number can take its original position. If I am making this formula, it is very easy. It is very easy to calculate total such arrangement by making some for loop in the code. If I say about the coding part, if I have this formula, it is very easy to solve this problem. What is our coding part? I will show you. So how I can making it? How I am making it? See, I am just first importing. This is actually our formula. Okay, whatever I have shown you, the formula. This is our all the formula. That is our formula. The same. It is very easy. The same I have made. Minus 1 to the power k plus 1, then into that one, minus 1. Yes, minus 1 also be there, because there is an plus and minus. Okay, plus and minus also there. So minus 1 to the power I plus 1. If it is 1, 1 plus 1, 1 plus 2. So that minus and plus I have also to arrange here. So you can see here that minus 1 to the power k plus 1, I am making every for loop up to 1 to n plus 1, up to I equals to 1 to n. So I am making it as an for loop, and for minus 1, whatever the formula have, to the power I plus 1, so to the power k plus 1 p divided by p means math dot factorial n I am making, because it is taking again and again, so I am just fixing it at one time. So p divided by math dot factorial, because I am fixing it ncy. So nci means, I know that nci means n factorial divided by I factorial into n minus I factorial. So this formula I am making here, this one. This one I am making into n minus I factorial into method n minus n minus I means n minus k factorial. Yeah, it is very easy. Only 4 or 5 lines I can make the solutions. Okay. Okay, so this was the problem and this was the solution. It is very easy to solve, but I have to identify that it is the like a it is like I have to make sure that it is an derangement problem. I have to make sure that it is an derangement problem. so that I come to this all the formulas. And after that, this formula if I'm putting, I can very easily get this answer. Like for trying, I am just making it suppose I am taking input as a 3. You can see the 4 is the answer, correct answer. If I am taking like 4, I'm taking like a 4, it should be the 15 should be the answer. You can see the 15 is the answer. If I can take 5, we can say that 76 is our answer, right? So in this way I can make it. Okay, I'm stopping here.